this lesson is sections 6.4, 6.5, and 6.6. So in our first example, before we get into anything, we are given the points A, B, and C, and then we are told that R is the midpoint of AB, S is the midpoint of BC. We want to find the slope and distance of AC and of RS. So if we started with AC, because I already know all those points, we'll do the slope first. So that's going to be -2 minus 4 over 4 minus -6. So -6 over 10 is -3/5. As for my distance, oh, hold on, I should not have labeled it this way. I don't want to be accurate. We're going to call it M of AC, because that was the slope. Distance will just be the capital letters AC. So this is going to be 4 minus -6 squared, -2 minus 4 squared. So that's 10 squared, or 100, plus 6 squared, or 36, square root of 136. And we haven't done a lot of reducing, but if I needed to reduce this, I would look for any number inside this that is a perfect square. So like 136 can really be written as 4 times 34, because 4 is a perfect square. So this would really be 2 root 34. Okay. So now we're going to do RS, but I need to know what the ordered pairs are of R and S. I could either find the midpoints, or because they're graphed on here, I could just calculate them, count them. So that's -2, 6, and this is 3, 3. So if we do the slope of RS, we're going to have 3 minus 6 over 3 minus -2. Ooh, look at that. Already, they have the same slope. This line here, RS, had the same slope as this line here, AC. Now let's do the distance of RS. So we're going to do 3 minus -2, or 3 plus 2 squared, and 3 minus 6 squared. So that's 5 squared, which is 25, plus -3 squared, which is 9. So this equals the square root of 34. So it looks similar to the other distance, but this was 2 times root 34, and this is just root 34. So this side here was actually twice as long as this side here. So we actually have a special name for the segment that we formed by connecting the midpoints of these sides. And the relationship we see here between the mid segment, which is what that's called, and the side that's opposite it, we ended up with them being parallel, and we ended up with one of them being twice as big as the other. So here's our definition. Midsegment is the segment that connects the midpoints of the sides of a triangle. Here's all 3 midsegments in a triangle drawn. You could draw just one at a time. You could draw them all. It does not matter. And then here's our triangle midsegment theorem. The side is parallel to the midsegment, and the side equals 2 times the midsegment. So here we have a walking path BD in a park, intersects the sides of the park at their midpoints. So they're telling me BD is a midsegment. Before I go any further, I know the length of the midsegment is 68. I know the side that's parallel to it is twice as much as the midsegment. So 2 times 68 is 136. So I'm going to fill that in on this side over here. You walk from A to B to D to E, and then back to A. How many yards did you walk? So we just want to add up all our measurements here. So I know this side and this side now. I don't know AB, but if B was the midpoint, then these would have been the same, so I could put 90 there. And D was the midpoint of this side, so each of them would be half of 216, or 108. So now I could find how long we walked. 136 plus 108 plus 68 plus 90. 136 plus 108 plus 68 plus 90 on my calculator, and we get a total of 402 yards. All right, here's try 2. You can pause if you'd like. Answers are posted online. The triangle inequality theorem says that the sum of the smallest two sides must be greater than the largest side. So whatever the three numbers of the sides are, I would add together the two smallest and compare it to the other number, and as long as that sum is greater, it can form a triangle. If the sum is not greater than it, if it's less than it, or if it's equal to it, it will not actually form a triangle. So let's determine if we can form a triangle with these side lengths. So in choice A, the two smallest are 5 and 7. So those are the two I'm going to add together. 5 plus 7 is 12. I'm comparing that to the other 12. Not greater than. So no, it does not make a triangle. Here's 4 and 9 are the two smaller ones. So 4 plus 9 is really 13. I'm comparing 13 to the 13 to the 12. Which is true. 13 is greater than 12. So yes, these three numbers will make a triangle. My two smaller numbers here are 3 and 3. So 3 plus 3 is really 6. Comparing that to 5, yes, that is true. So that will make a triangle. And my two smallest here are 7 and 7. So I get 14. Comparing that to the 18, not greater than. So no, it would not form a triangle. Here's a try problem for you. Pause if you'd like. Answers are posted online. For example 4, if two sides of a triangle are 7 and 13, find the possible range of values that can represent the third side. So we have one instance where the missing side is the biggest one. So the numbers would be 7, 13, and x, which means 7 plus 13 has to be greater than x. But there's also the scenario where 13 is the biggest side. So that would have been x plus 7 is greater than 13, and x is greater than 6. So what I really have is it has to be a number between 6 and 20. And the easiest way to go about this, instead of having to set up these two separate things, we know we're going to write a compound inequality like this. On one end, I'll subtract my two original numbers. On the other end, I'll add my two original numbers. And that's all we're really going to have to do here. So here's a try problem for you. Pause if you'd like. Answers are posted online. The longest side of a triangle is opposite the largest angle of a triangle, and vice versa. Largest angle is across from the longest side. And then also the smallest angle of a triangle is opposite the shortest side, and vice versa. The shortest side is opposite the smallest angle. So what this allows us to do is if I know one set of information, say I know the angles, I could then place the sides in order from least to greatest. Or if I knew which angle was the biggest in the picture, I should know what side is the biggest in the picture automatically. So we are given the side lengths of this triangle, and we want to list the angles in order from smallest to largest. When I'm doing something like this, it helps me to just name the sides first from smallest to biggest. So my smallest side here was JK. Then my next smallest side was KL. And my biggest side was JL. Opposite JK was angle L. So we're using the letter that wasn't part of J and K. We're using the only letter that was not part of it. So my smallest angle is L. So then opposite the KL, the angle that can't have been part of KL would have been angle J. And then the one that couldn't have been part of JL was angle K. And that's how I could put my angles in order from smallest to largest. I look at the three segments and I give the letter that was not included, right? So with J and K, there was no L. With K and L, there was no J. With J and L, there was no K. So you can try this one. Pause if you'd like. Answers are posted online. For example 6, we know two of the three angles. We do have to find the third. So if I add together 45 and 56, I get 101. And taking that away from 180, my last angle is actually 79 degrees. So I'm going to do the same idea as I did with putting the sides in order first. I'm going to put the angles in order first. So my smallest angle was G, then H, then the biggest one was F. So if I'm talking about angle G, the side opposite it was FH. It was the two letters that we used that were not G. So when I used H, I wasn't using G or F. So the next one would be GF. And then for the last one, I wasn't using G or H, so my biggest side would be GH. And that would be how I put the sides in order from shortest to longest. Here's a try problem for you there. Pause if you'd like. Answers are posted online. The last thing we'll talk about is called the hinge theorem, because it is actually talking about, like, pretend you had a door, the door opening, the door, let's pretend they're the same, doesn't matter, two different doors in the same hallway. If you open one door wider and you get a bigger angle there than this one, then the opening is bigger than this one. So that's really all it's saying. If you have two sides that match, the angle inside is going to tell you which one has a bigger opposite side. And the reverse is true. If you had two sides that matched and you knew this opening was bigger than this opening, that would mean this angle here has to be bigger than this angle here. So what we're really going to do is we're just going to compare the missing side or the missing angle in two triangles based on the fact that they already had two sides the same. So in example A, DC matched and they had AC and BC that matched. So really I'm comparing AD and BD. AD is opposite the angle that's 70 degrees, and BD is opposite the angle that's 68 degrees. So if I'm really comparing these numbers, then AD would be greater than BD. For part B, angle ABD is in this corner. That is opposite the 5.5. Angle BDC is in this corner. That is opposite the 5. So we have again a greater than. The measure of angle ABD would be greater than the measure of angle BDC, because the 5.5 opposite that angle was greater than the 5 opposite that angle. So this is the last one for you to try. Answers are posted online, and that is the end of sections 6.4, 6.5, and 6.6.